Hello everyone, and welcome to the MediPedia demo. I'm Aditi, and today I'm excited to walk you through the features, functionalities, and a detailed code walk of this amazing platform. Let's start with an overview of MediPedia and the technology stack powering it. MediPedia is built entirely on open source technologies. It utilizes Python for backend development and leverages advanced natural language processing techniques. We utilize Hugging Face for embeddings and FAISS, which is Facebook AI, semantic search for vector storage, ensuring transparency and accessibility and enabling us to provide intelligent responses to user queries. Now, let's see the overview of the system design. Let me share my screen. This flowchart gives us a brief overview of how the system is designed. So, here's the breakdown of each step. The user prompt. So first, the process begins when a user provides a prompt. This could be a question, command, or any input. Then comes the vector database, which is the Facebook AI similarity search, as we discussed. The user prompt is processed through the FAISS, which is a vector database, and it is likely to help with the similarity search, allowing the system to find relevant information based on the input. Then comes the sentence transformers. The processed prompt is then sent to the sentence transformers, a powerful tool for encoding sentences into dense vectors. These vectors capture semantic meaning, enabling better understanding of the context. We have also employed LangChain. The LangChain is useful for the modeling purpose. So basically, the transformed data from the sentence transformer is embedded or modeled in LangChain. LangChain likely performs additional language-related tasks, such as natural language understanding, context generation, and response formulation. The LangChain has input from the documentations or the data that we have provided. So basically, that data is first pre-processed before reaching the final step. That is the LangChain. This ensures that the data is clean, structured, and ready for further processing. Here, we have also used the Llama 2, which is the Meta AI LLM. And then all of this processing finally leads to a response. Now, let's dive into the code and understand how MediPedia works under the hood. Let's go to our code base. Yes. So here we have two important files. One is ingest.py and the second is model.py. So in ingest.py, we are importing the necessary modules from the LangChain library, such as text splitters, document loaders, embeddings, and vector stores. We define the paths for our data and the location where the vector database will be stored. Next, we define a function called as createVectorDB, which then helps us to create the vector database. First, from the directory loader, we load the PDF that we are using as the knowledge base for our application to feed it to our system. Then we split the document into chunks using recursive character text splitter to extract the text. Then, after that, we have initialized the Hugging Face embeddings object with the model that we are using for the sentence transformer, which is also open source. Finally, we create the vector database using the FAISS module, passing the extracted text and embeddings. Once the database is created, we save it locally at the specified path that we have declared above. So basically, after running the script, we will get our vector database stored in the system. Next important file is the module.py. Sorry, model.py. So that is basically the Python script where we have actually uh, described the model and the UI code for it. So here we have first created a custom prompt template, which instructs the chatbot on how to respond to the user queries. Next, we have functions to set up the QA retrieval chain. QA meaning question answer retrieval chain, and load the language model, that is the meta LLM. The retrieval QA chain then utilizes the language model, vector database, and the custom prompt template to provide accurate response to the user queries. We also load the language model, which is crucial for generating the responses based on the user queries. Finally, we have a function to handle the user queries and generate responses using the QA chain. And next here, we have defined the chainlet UI code. So basically, we are using Chainlit, which is very, very similar to Streamlit, but is open source and helps us run the application um, locally and not on some server. So now, let's pull up the GitHub repo where I have pushed all my code and see how we can, or anybody can access this chatbot on their machine. So here's my GitHub repository where you can find all the code and resources related to MediPedia. I have also given all the detailed instructions on how you can clone the repository to your own machine and run the application. So since I have the code base, now let's see the actual working of the application. So to run the application, I need to run this command, that is chainlit run model.py. So when I hit enter, it will initiate the chatbot. So this is the chainlet interface that we had defined in our code. Now, let us give it some time, and then our application will be generated. Yeah. So here I have structured the code such that it first prints the message, "Hi, welcome to MediPedia, and how can I help you?" So for demonstration purpose, let's ask it a question regarding a certain disease. Let's say we can ask him about hypertension. So I will ask, what is hypertension? Now, as you can see, every part of the code that we have written, that is about using the retrieval QA chain, then the document loader, etc. Each and every step uh, can be seen in detail. So since I want to highlight one drawback of this application, which is since it is running on the CPU and not on any GPU or um, remote server, the response time of this chatbot is quite um, low. So that is the only drawback. But apart from that, the advantages I can say are This is built completely on open source technologies, and anybody can run it on their local machine. So let's wait for the chatbot to give us the answer and finish its processing. So sometimes it may throw an error such as could not reach the server uh, because of the step that we are running it on the CPU. We can minimize this and wait for the chatbot to respond. Now, as you can see, it has provided us with an answer about what is hypertension, its condition, and uh, the effects that it can cause. Also, uh, I have written it in such a way that it also cites the sources from which it has provided the information. That way, we can ensure that the information that it is providing is valid or just made up information. So that ensures the quality of the information that we are gaining from it. Now, I should also make it a point to help you understand that I have not um, let the chatbot provide its own outputs, meaning I have coded it in such a way that it will not um, give any unsolicited advice regarding any medical condition and act as a doctor if it doesn't know about anything. So, if I ask about what is cancer and how can I treat it, or let's say if I want to ask what are the symptoms of cancer and how can I treat it. So now again, let's wait for the response. It may take some time, as I've already mentioned that it runs on the CPU. So let's be patient and wait for it to respond. Let's wait for a few minutes. Yes. Now we can see the responses produced. So if it doesn't know any answer to any question, it will not make up the answer and it will not try to act as a doctor, uh, which in some cases might be very tricky because it shouldn't act as a doctor anyway. So it is um, it is programmed to say that I don't know the specific systems and how symptoms of cancer and how to treat it as a general practitioner. It is best to consult with an oncologist or professional advice and treatment options. So yeah, this is its response, which was very what we can say. It is very valid and not something made up as it should be. And also, we have cited the resources from where it has garnered the information. So to conclude, I can say that some of the real world applications and use cases of Medipedia could be patient that seeks information about their symptoms uh, and needs to know about something and increase his or her medical knowledge. A second scenario could be a medical professional that uses Medipedia to stay updated with the latest research and treatment options. This can enhance their clinical practice. So basically, this chatbot is useful to improve one's knowledge about different conditions and not to be taken as a medical advice or a replacement for a doctor. It is only supposed to provide knowledge and improve the um, information that it provides. And that concludes our demo of Medipedia. Whether you're a patient, caregiver, or a healthcare professional, Medipedia is here to empower you with reliable medical information and assistance. Thank you very much for joining me and see you next time.